Hello everyone, my name is Joe Bierer and I'm with Bierer Meters, and today we're going to talk about our PD800W, our wireless phasing meter, and we'll use just a few accessories that's behind me here, our hook probes and bushing adapters, and we'll do several things. We'll phase capacitive test points, we'll take a nominal primary voltage reading, we'll phase URD, which stands for underground residential distribution, and then we'll phase overhead as well. And what's very unique about this tool is we'll actually phase difference of potential, so that's much different from your traditional wired phasing meters. So in other words, we'll actually phase from our secondary 12208 and capacitive test points to primary potentials. So that's going to be a very unique feature with this tool, and hopefully everybody will enjoy this and be very informative. So here we go. All right, before we get started, we usually always want to test the tool before we take our reading. It's very unusual if you do not do that, but as a good rule of thumb, for safety reasons, we recommend that you test this tool prior to use in any situation. So using the PD800W, you'll notice the back on the device, the first position is off, the second position is DEG, which stands for degree. The third is URD, which stands again for underground residential distribution. The fourth is OH, which stands for overhead. And the fifth is a test position. And you can self-test the devices prior to use, and also in a known voltage. So we have a dual phase power supply here below me, which is usually in the box in your kit when you get the device. But we'll go ahead and test it here on the ground also. But first again, we want to flip this to the test position. And you'll notice the tool, it reads 510. It gives a sequence of LED lights. The 510 is basically a processor math test. So if the tool is not registering 510 on the display, we recommend you send the tool in for calibration. If I hold the tool over to the test position, it reads the battery voltage. So that's the internal battery voltage of the tool. So it's over 9 volts. It has a 9-volt battery here behind the quick change. So that's testing this meter probe, but to test the reference probe, I essentially do the exact same thing and watch the display on the meter probe. So on the reference probe, turn the tool on. You'll notice on the meter probe, I read a 51.0 through all the switch positions. If I hold it in the test switch position, it reads the 9.6, so this battery is good as well. So both of these tools have brand new batteries in them. It's not unusual for it to read a little over 9 volts if it does have brand new batteries. Once I've done that, again, I recommend that you test the device on a known potential, and the dual phase power supply that is an option with the kit, it should register 180 degrees out of phase. So in order to test the device on the dual phase power supply, if you turn both probes in the DEG switch position, so the meter probe is in the DEG and the reference probe is in the DEG. Now I can actually test to see my out of phase reading, and it should be near 180 degrees since this is a dual phase power supply. It's powered by a 6-volt battery. Okay, so we see our blue light, a flashing yellow light, and 180 degrees. All that is correct. Okay, now that we're ready to take our live potential tests, the first thing I'll demonstrate is using the PD800W on secondaries. So again, it's a very unique feature about this tool. It's not just used for distribution and transmission meters or transmission readings. You can actually use the tool on secondaries as well. So again, the first thing we'll do is we'll put this device, both meter probes, in the DEG switch position, and we'll check our phase rotation on the secondary tabs, the 12208. So both meter probes are in the DEG switch position, and now I'm ready to take my phase angle readings. It doesn't matter where you start when you do this. You can start on the left side or the right side. You just want to pick any two of the 3 phases and take your readings. So I'm going to take my reference probe and put it on my X3 bushing. You'll notice I get a white light. On the reference probe in the DEG switch position, it's essentially telling me this tab is energized, or this bushing is hot. So on the reference probe, again in the DEG switch position, if the white light comes on, that's telling me that it's energized. You need at least 50 volts for this light to come on. So in order to phase, I want to verify that all three of these are hot. Obviously you cannot phase if they're de-energized. So I can touch my X2 bushing, I get a white light. I can touch my X1 bushing and I get a white light. So I know all three of these secondaries are in fact hot. Now I can begin phasing. Again, I'll touch the X3 bushing with my reference probe. I'll touch the X1 bushing with my meter probe. There I have my near 240 degrees and a red light. I touch the X2. I have my blue light and my near 120 degrees. So having done that, what I've done is I've not just phased these tabs, I've also developed the sequence in which these tabs are wired. In other words, I used my reference probe on the X3 bushing. My meter probe was on the X2, I had my blue light. My meter probe was on my X1, I had my red light. So that tells me my sequence is actually from X3 to X1 or right to left. If a customer has a phase rotation device, in other words, a clockwise or counterclockwise tool for secondaries, you can actually replace that tool using this device. In other words, if a customer uses that device, the clockwise or counterclockwise device on this situation, and it tells them this is counterclockwise, from that point forward, the PD800W, if your sequence is from right to left, is considered counterclockwise. So you would essentially replace that tool using a primary rated tool versus a secondary rated tool in this situation. Now I can perform that same thing on my primary. So again, I just did my secondaries. I can do it on my primary. The first thing I'll demonstrate is on my capacitive test points. So again, I'll pick any two of the three with my reference probe. I get a white light. I know that capacitive test point is hot. Go to my second bushing. I get a white light. I know that capacitive test point is hot. And on my third, I also get a white light. So I'll know all three of these primary elbows are energized. So now I can begin phasing now that I know they're energized. So my reference probe is on my H1B. My meter probe is on the H3B. And I get 120 degrees out of phase, my blue light. Put the meter probe on my H2B. I get a red light in near 240 degrees. So having taken the readings, I know my sequence is from bottom to top. In other words, H3B leads H2B leads H1B. So the 120 degrees leads 240 degrees, 240 degrees leads 0, or my reference phase. So again, my sequence is from bottom to top. The next demonstration will be phasing difference of potential. So at the beginning of this demonstration, I talked about the unique feature with this device is phasing difference of potential rather than the same potential. So here I have my reference probe on my X2 secondary bushing, and now I'm going to take my meter probe and go over to one of these capacitive test points and determine which primary is the source of this X2 bushing. I have both devices in the DEG switch position. I have my reference probe hanging on my X2 bushing, and now I'll take my meter probe and start touching each capacitive test point until I get a 0 or near 0 reading. So the H1B bushing, I have my blue light be near 120 degrees. My H2 bushing, I have my white light, my 0 degrees. And my X3B bushing, I have my red light coming up near 240 degrees. Again, I'm demonstrating phasing different potentials. I have 120, 208 on my secondaries. On my primary, capacitive test points can range anywhere from 2 to over 300 volts. So I determined my H2 bushing is in fact the source of my X3 secondary bushing. All right, the next demonstration, again, is going to be a difference of potential demonstration. And what I'm going to do is I have my reference probe already inserted into my primary bushing. I have my cable that feeds our overhead. I have it stood off on the feed-through bushing. and I'm going to phase from this side of the switch over to the line side of the switch and determine which phase, assuming I had no nomenclature, there was no markings whatsoever, I can determine what phase is actually feeding that side of the switch. Again, I have both probes in the DEG switch position, and now since I have power there demonstrated by my white light on my reference probe, I know this is in fact hot. I can go ahead and determine what phase is feeding that side of the switch. So again, you can touch any one of the three phases. It doesn't matter which one you start at. So I'll just start on the left side. I have my red light. It goes up near 240 degrees, so I know in fact this does not feed that primary bushing on the other side of the switch. The second phase, I have my blue light near 120 degrees. I know that is not it. And my last phase, I have my white light 0 degrees. So I know in fact this primary bushing on this side of the switch does feed the other side. So they're in phase. Okay, I'm going to use this opportunity to demonstrate what not to do when you're phasing with these devices. In other words, you don't want the housings of these devices to be within 2 feet if you can help it. Sometimes, obviously, you can't always control the situation you're in, but this situation right here forces me to put the housings within 2 feet. So I can just use the meter probe angle to adjust and make sure I get a good reading. In other words, if I come in here away from the reference probe, I get my white light, a good white light, a 0 reading. If I start moving the housing towards the reference probe, you'll notice that number gets out of whack, so to speak. It's not a reliable reading because I have a flashing yellow light now, so I don't like that. It's not making me comfortable. So really all I have to do is just move my housing away from the other housing, try to get more than 2 feet, at least 2 feet away, and get a reliable reading. So the next demonstration, I'll be phasing URD and same potential. In other words, I have 13.8 phase to ground here and 13.8 kV phase to ground over here in this pad mount. And I'm going to phase between this switch and that 3-phase pad mount and determine what phase on the pad mount, the 3-phase pad mount, is feeding this switch. So again, I have my reference probe in the DEG switch position. My white light is on. I know that bushing is energized. In fact, it is energized. And now I'm going to take my meter probe again in the DEG switch position, and I'm going to walk over here to the 3-phase pad mount and determine what phase is feeding this reference probe bushing. It doesn't matter which bushing I begin with. I could go ahead and start with the bottom one and just determine if that is in fact in phase with that bushing over there on the switch. It is in phase with it. I have my white light in near 0 degree. But let's just say I started with the top bushing. Again, I had no nomenclature, no colors, no markings whatsoever. I have my red light near 240 degrees. So that is in fact not in phase. My H2A bushing, I have my near 120 degrees, my blue light, so that is also not in fact in phase with that bushing. So my H3A bushing is the phase that is in fact feeding where my reference probe is at, inserted into that primary bushing. So the next demonstration, I'm going to be demonstrating the PD800W meter probe by itself as a nominal voltage detector being used in a URD situation. So what I'm going to do is I'm going to flip the switch to the URD switch position. I'm going to insert it into every bushing, all 3 bushings on this pad mount, and I'm going to determine what the nominal potential is of each of these phases. So first, flip it to the URD switch position. Now I'll insert it again into any one of the 3, it doesn't matter which one I start with, and take my nominal voltage reading. So I have 17.2 kV in my H1A bushing. .4 kV in my H2A bushing. and 16.6 kV in my H3A bushing. Okay, now I want to demonstrate using our 0 ohm extension adapter. And what this will do is it will actually get my housing of my meter probe further away from this ground plane. So the edge of this 3-phase pad mount is all grounded, so that affects the reading of this device in the voltage detector position. So in other words, the URD and OH switch positions, this device is being used as a voltage detector, okay? So I want to get away from grounds that will affect the reading or another phase. So by doing that in this situation, if I use our 16-inch 0 ohm adapter, so I'm going to go ahead and attach my 0 ohm extension to the meter probe, simply by threading it on the end of the probe. And now I'm ready to take my voltage readings as I did previously. I still have my meter probe in the URD switch position, and I'm going to insert it into the top bushing as I did a moment ago and take my reading. And now you'll notice my reading's 14 kV. So again, it's much more accurate. That's basically within 1% of the true RMS voltage on this pad mount. It's a 13.8 phase to ground. This is 14 kV. So what I've done is I've removed this housing away from this ground plane close to the cabinet here. So I've basically done two things. I've made this work method a lot safer simply by removing this housing close to the ground, and on top of that, I've made this reading much more accurate. Instead of reading 17.2 kV, I'm reading 14 kV. So I can go ahead and check my other phases as well. Even though they weren't as close to the cabinet, the reading should be more accurate, and they are. I have 14 kV again, 14.2. I'll check my third phase, and again I have 14.2, which would be more common to have a slightly higher reading because now I'm working down closer to earth. And in fact, since I'm a ground plane, if I approach this device, in other words, you'll notice when my hand gets close to this housing, that reading goes up. It's going up because I'm a ground to this device. So it starts coupling with me. So in other words, I don't want to short stick this device because the reading will go up. I don't want to approach this device with my body because the reading will go up. So keep your distance from this tool, again, about 2 feet or so, just so it doesn't adversely affect the reading. Okay, the next demonstration, I'm going to phase from my 13.8 kV to ground pad mount to some overhead conductors. It all is the same potential, but what I'm going to demonstrate is some of the distance this tool can phase. In other words, I can actually get over 100 feet away. So this is an FCC licensed tool. In other words, we're only allotted so much power output per the FCC with this device. So in other words, I can't output a lot of power and phase a mile away or something like that, because you start affecting other customers that use wireless and remote devices. So rule of thumb is if I can't see the other probe, give yourself about 100 feet. If it's line of sight, in other words, I can actually see the other probe, you can approach about 300 feet. So in this scenario, we're going to be about 50 feet away. I'm going to insert this reference probe into this URD bushing. I'm going to have the device in the DEG switch position, and the meter probe will also be in the DEG switch position. And again, I'm going to pick any one of the 3 phases, insert the reference probe. I do in fact have a white light, so I know this bushing is in fact energized. It at least has 50 volts on it, so I can go ahead and phase and determine what phase overhead is the same phase as my URD bushing. Okay, as I mentioned, we have our reference probe. It's in the URD bushing in the 3-phase cabinet behind me, about 50 feet away. I want to put my meter probe in the DEG switch position as well. We're going to phase from our overhead to our underground. I've inserted a hook probe on here just so I can make easier contact with the conductor. It's much easier using an adapter like that working on a stick. Obviously, if you're in a bucket and you're close proximity, you may not need an adapter, or maybe just the straight probe adapter. But in this case, I'm going to use the hook probe just to make it easier to land this meter probe on the conductor. So you can start with any one of the 3 phases. I'm going to start with the outside phase first. I'll land the meter probe on it and see what my phase angle is. I have my blue light near 120 degrees. So I know that in fact is not the phase. Go to my middle phase. I have my white light near 0. So this in fact is the phase that my reference probe is on. And on my outside phase, I've done something here where it demonstrates some of the situations you may encounter in the field. And what I've got is I've actually have a de-energized phase. So on my switching cabinet that feeds this overhead conductor, I actually have this phase de-energized, and it demonstrates some of the weird phase angles you can get. In other words, this phase is getting induced a potential from the middle phase. So the phase angle is not pretty. So this is telling me that something is wrong. So basically what I would do in this situation is I would ride back and determine where this becomes a 240 solid red light. Okay, so just a moment ago I actually showed an issue we had where this outside phase was being induced from the middle phase, and the phase angle was not what we would call a pretty phase angle. We had a flashing D to Y light, a yellow light. So I fixed the problem. We found where the problem was at. We fixed the problem. And now I'm going to come back and see if my phasing is correct. So I'll try this outside phase again. You'll notice I already have a red light, which is my 240 light. In other words, I actually start detecting the phase at basically near minimum approach distance before I actually physically contact the phase. If I land the probe on the conductor, I have my solid red light, my near 240 degrees. So in fact, we did solve the problem. We fixed the problem. My phasing is good. My sequence is the same, it's good. In other words, my outside phase here is 240 degrees. My middle phase is my white light, my 0 degrees. And this outside phase is my blue light, my 120 degrees. So again, just like we did in our underground situation, we actually determine our sequence here. So in other words, if we called this phase our field phase, we know our sequence is from road, middle, field. So in this demonstration, what I have is I have our reference probe hanging from our overhead conductors behind us. Again, it's about 50 feet away. I have it in the DEG switch position. And on my meter probe, I'm going to put it in the URD switch position. And in each one of these bushings, I'm basically going to do 3 things simultaneous. And that's a very unique feature with this tool. I believe it's the only tool manufactured that can perform this function, where I'm going to phase sequence, and take a nominal voltage reading all at the same time. So again, I can start on any one of the 3 bushings. I have my 0 ohm extension attached to my meter probe, so I'm going to get a much more accurate reading when I do this. So I'll start with the top bushing first. You'll notice before I even insert it into the bushing, I get a red light. So I know this is my 240 degrees. It's not in phase with my reference probe. And I'm getting about 12.5 kV. So that's my nominal voltage reading. The H2A bushing, again I have about 12.5 kV, a blue light. This is not where my reference probe is attached. And my H3A bushing, I have my white light, about 13.8 kV. So that's my nominal voltage reading phase to ground. Again, it's much more accurate. In this case, it's within 1% of true RMS. So I've done 3 things simultaneous. I've determined my 13.8 kV phase to ground. My H3A bushing is in phase. And I've also determined my sequence. So my H3A bushing is leading my H2A, which is 120 degrees out, and my H1A, which is 240 degrees out. So again, we've done 3 things simultaneous here. We've taken our nominal voltage, we phased, and we phase sequence using our reference probe over here on my overhead conductor. If you want to determine what phase is what, so actually phase ID, we encourage you to look at our phasing ranger. In other words, this white box right here, it would connect to a base station, it would replace my reference probe, and in that case I would actually do 4 things simultaneous. So the addition would be phase ID. So again, I would take my nominal voltage reading, I would be phase sequencing, I would phase, and I would actually phase ID, all in real time. So again, that's a very unique feature. I believe we're the only manufacturer that does that. And again, you can do it all in one move using this one probe. So thank you for watching. Again, my name is Joe Bierer with Bierer Meters. If you guys need any assistance or help using our devices, please contact us at customer service or customer_service@bieremeters.com, or you can call us at 803-786-4839. Stay safe and have a great day.